Hi everyone, today we're gonna make this lovely growing mushroom animation in Blender using the new geometry nodes. It's pretty easy to control, it's just on a Bezier curve, and you can use this one slider to grow the thing, which is actually really cool. So I'm going to show you how to make it. There's also a little variation, so you can make a squat big mushroom or a long thin one. And yeah, let's get into it. I'm gonna work with the curve to mesh node, and we're also gonna learn a bit about vector math. I will try to explain everything as we go along so that even if you are just starting out with geometry nodes, you can understand, and so you can learn how to work with this amazing feature. But before we get into it, consider helping me out by dropping a like on this video, and you can also subscribe to stay updated on future tutorials. You're gonna need Blender 3.4 or above, so if you're still on the 3.3 as it is currently officially released, you should download the 3.4 beta version or higher. And we're just gonna delete the default cube and add a Bezier curve. Now I don't really like the shape of how it's looking now, so let's just move it over one spot over here and then put this on 3D cursor and rotate it 90 degrees like that. And let's just rotate this back, put it back to bounding box, and I think it's 25 or 45 minus 45 degrees. So we have this lovely straight line. So let's go to our geometry node editor, which is down here, and make a new group. And the first thing we want to be doing is actually subdividing this curve so it has a bigger resolution. But we want to subdivide it in a special way. So let's start with a subdivide curve and put that at 4. And now let's copy this and put another one there. You might think, why should you put another one there? But we're gonna actually use this one only on the top half of the mushroom. Since the cap is there, you want more detail and you don't want a bunch of detail over the whole model. So I'm gonna show you how to do that. We will just take an index node. And we will take a math node and set it to greater than. And then we also get a multiply node. This is the number of cuts that are going to be made per cut we already made. So let's plug that into here. Put this to 2, so it's only the top 3 vertices. Multiply by 8. 8 is a good number. And then just plug that in here. Next, you're gonna want to add a curve to mesh node. And let's add a quadrilateral. A quadrilateral, which is basically a square, but it's a curve. Plug that in. And if we go to wireframe mode, you can already see that... Wait a moment. Okay. So you can see there's actually a lot of detail on the bottom now, and that's not what we want. So let's just select our curve, go to edit mode, and then right mouse click, switch direction. Now we get what we want. Maybe make this a little bit bigger. Like that. And obviously it's still way too wide. So let's put this to 0.1. That's a pretty good size for now. We're going to change it though using the curve radius. And we're going to plug that in here. So now it's very small. But that's okay. Just put that over here for a second. And we're gonna take a new parameter, which is the spline parameter. And we're gonna take the factor. The factor of a curve is 0 at the starting point and 1 at the end point. Doesn't matter how long the curve is, it will go from 0 to 1. Let's plug that in the radius and see what happens. Okay, so we can see this cone shape, because obviously it outputs 0 at the start and 1 at the ending. But we can use another node called a float curve to actually give it a shape. So this is the default one. It's just linear, as you can see. Let's pull this out a little bit, like that, because we are actually going to use this float curve to make our mushroom shape. And we're going to do that by just literally drawing the profile like that. So let's create this hump over here. Maybe put another node here so it's straight. And it's beginning to look like something, but it's very narrow. And we don't want that. We want it to be thicker. So let's get another math node. Let's get this multiply one. And here it's multiplied by 8. It's already beginning to look like a mushroom over here. Oh yeah, you're gonna want to fill this up by going to the curve to mesh node and fill caps. I should have mentioned that earlier. And so you can be pretty creative with the kind of shape you want for your mushroom. I tend to like this kind of shape. I think it's pretty good. You can also put this higher, maybe multiply that and bring this down. Now we have a very large head with a thin body, but I kind of prefer the more thin ones, just a bit regular shape. And so obviously if you look from the top, it's pretty square. So let's put a subdivision surface. It's gonna smooth everything out. And as you can see, now it's pretty detailed. So let's bring it down. There's a lot more detail up here than down here. So we've saved a lot of that. So the next node we're gonna add is a trim curve node. This is actually gonna allow us to grow the mushroom. And we're gonna put that right at the start over here. So let's plug in our first parameter, or our first variable, I guess, and put that to the end. Go to group and call this grow. And we can go to our modifier tab and we will see our modifier here. So let's try this out. Okay, so it kind of works, but it retains its thickness. So it's very thick when it's small, and we don't really want that. We won't want it to disappear, but we want it to be less thick. So how do we do that? Well, we can do that by messing with this multiply node over here. We will do that by setting a map range node, and it's going from 0 to 1 to another minus a maximum. And in this case, we're gonna want the smallest stage of the mushroom here. I'm gonna put 0.5, and then the biggest stage, let's put 9 over there. And then let's connect our grow to the value. And this result we're gonna plug into the multiply, and we can see it already works. Now it gets thicker as it's growing, so it's pretty neat. And you can mess around with this. Maybe it needs a little bit thinner, like that. And you can even put another float curve here to regulate how the thickness changes. So maybe you want it to stay thin at the start and then get more thick more quickly, or it gets really thick at first and then it kind of slows down. So it's really thick, and it slows down. Oh, it doesn't even slow down. Yeah, there we go. It's still all the way. It's already on half, so it's very thick. Now we do this. It gets very thin. And now it's the normal shape. I like to put it just like that. Just a little bit. So it gets thin, big. There's actually one thing I forgot to mention. You can make it look a lot better when it's tiny. Just pull this out, and we're going to create another one, because we're going to blend between two shapes as we grow the mushroom. So let's make actually a little less thick and create a mix node. I'm going to mix these two values. And we're going to mix them based on the grow curve. So maybe a little thicker actually. And let's actually make another float curve. And let's see how it looks. It's a lot better. Okay, so we have our mushroom shape right here, but we want this area to be caved in. So how do we do that? We're gonna use the normal for that. So to do that, let's first add a set position node. And let's add a normal field. And what we essentially want to do is look for the normals that are sticking out here. So normals are sticking out all across our mesh. These are our normals. And we want to look for these, for the ones that stick out in this ring over here. So let's put a vector math node and also put a separate XYZ node. And we're going to set the vector math node to sine and plug those up. And then we want to do another math node and set it to multiply and multiply by -1. So this will make it look for only the negative z value, and the sine will make sure it looks all around the z axis basically. So we'll choose this ring around the mushroom, and we're gonna push that up using the set position node. So let's plug the Z value in here, and we're gonna create another lovely float curve. This is my favorite node. And we're gonna stretch it out, and we're gonna wanna think about what is the Z vector output that is gonna be here. And we can do that by checking out the viewer node, the new viewer node in Blender 3.2. Excuse my typing, by the way. Get the viewer node, and let's plug it in and see how it looks. Okay. So I immediately see a problem. I rotated the mesh at first. So it's actually checking for the wrong thing. Because it's rotated, and we're just going to want to apply that rotation. And we can already see that it's checking this part, which is good. It's also getting this part. We're going to fix that later. But we want to define this selection a little better. So let's do that by seeing which part. I mean, I already know, of course, but which part corresponds to this area in particular. So this area needs to be white. And then we have the correct place. This is already better. So let's leave that for now. And we're gonna make a combine XYZ node. Plug that in. And let's plug that into the offset, see what happens. Okay, so turn off the viewer. Some stuff got moved up, way too much. So we're gonna want to make that a little less severe. Let's put a multiply node and let's set it to here. Okay, so it's grabbing a little too much of that base. Let's see how we can change that. Okay, it's getting better. Let's put another subdivision surface node in between these nodes. Let's put this to 1 and this to 3. And by now you are probably wondering why it looks so layered. That's actually because the resolution of the curve, you have to change that. You have to change that to 1. Now it looks better. Okay, now that we have this, let's organize this a little bit. Let's get this part over to the right. Put this over here, put this over there. Because this is all good, but we are missing something. If we change this now and rotate it, it does not work. It looks terrible. So what we actually want to do is this vector that we were looking for, so this one, we want to rotate that with the control point here. Or actually more rather, we want to change that by the control point as it is over here. Sounds complicated, but just follow the tutorial. We're just gonna use the basic vector rotation equation or whatever it's called. I'll put it on screen and we're gonna translate it into nodes. So first thing we're gonna do is go all the way back and add another trim curve node. And we're gonna put that after the subdivisions. And let's get a multiply node and set the multiplication by 0.8 because it's at about an like 4/5 of the way up. So we're gonna check in this area. Hi, this is me from the future. You actually don't need this multiply node. You just set the trim curve itself to, in this case, 4/5, so 0.8. You might want to change this based on your shape, but you don't need the multiply node. Next, we're gonna grab an attribute statistic node. Plug this in the geometry. We're also gonna get an endpoint selection node. Put that to 0 and 1, so we only have the endpoint. Put that into selection and put the curve tangent node. So that is the direction the curve points in. It outputs a vector. So if it was like this, the vector is like that. Plug that in and actually set this to vector first, like that. And plug that in. Now we are going to do some vector math. So let's get a vector math node. And we're gonna get the median. That's the one that works here. Maybe there's a better way to just get the vector of this node. If you do, let me know in the comments. And we're gonna grab another vector, just a regular vector, and set that to 0, 0, 1. So it's just a vector that points up. And what we want to do is, if it's rotated, we want to calculate the distance. Let's get annotation here. We're going to calculate this distance. So this is what we want to calculate, this, because we can use that with the vector rotate tool to rotate the normal field first in the y direction and then in the x direction. So first of all, we're gonna multiply our vector and take out the y component here by multiplying it by 1 and then 0 and then 1. So y is always 0. And next we're gonna get a dot product and a length. Plug that in. I'm gonna get the dot product of this vector and this vector, and then also get the length of this vector, and then we're gonna get another length vector, plug it into our z vector here, and we're gonna multiply those two values together. And then we have two more outputs left. They have to be divided by each other. So as you can see, we've translated this function on how to calculate the cosine of theta between these two vectors. We've translated them into nodes right now. So the output of this is the cosine of theta. So how do we actually get theta? Well, it's very easy. Just get the r cosine, plug that into here. So now we have the angle between the vector pointing up and whatever, I think it's the y direction it's pointing here. And we're actually gonna just copy this and plug this into here. And instead of having 1, 0, 1, we're actually gonna, oh, there goes my light. So instead of 1, 0, 1, it's gonna be 0, 1, 1. So this is our output for y, I believe, or x, and this is the output for y. So in between our normal here, we're gonna put two vector rotate tools. And then the first one we set to y-axis, and the second one we set to x-axis. And this is important. This has to be inverted. The y-axis has to be inverted, and the x-axis doesn't have to be inverted. And yeah, it's actually this one that needs to go to the y, it needs to be rotated around the y-axis, and then this one needs to be rotated around the x-axis. So we can already see an effect, but it's still weird, right? Because it's still, we have this part, and it's going up, and here it's also going vertically. So why is that happening? Well, it's actually because of this set position node, because we also have to rotate this vector here. So we're going to just do the same, copy these two, put them over here, and link them up. And here, bear with me, this is very important. We want to actually not invert this one, and we want to invert that one. Get the y value here, and get the value for x here. And let's see. Now it actually looks a lot better. You can rotate it and put it over here. It's not perfect, because look what's happening. We've rotated it over here, and now it's applying it over here. So why is that? Well, actually it's because it only works now in the positive x and y field. So here y is positive, here x is positive, and doesn't work in this square, this square, this square. So we're gonna fix that by going back to our vector math here. Just put that down a little bit, and let's get a separate x, y, z node. We plug our ending point vector in, and now actually based on whether x or y is positive, we're gonna basically give this a minus rotation. So instead of going 45 degrees, it's gonna be minus 45 degrees. We will get a float to integer, actually get two of those, and put them to ceiling, put them both to ceiling. And we will connect our X and Y outputs for that. Then we will put 2 map range nodes, 1, 2, and set them from -1 to 1. Both them -1 to 1. Plug our values in. And then here, let's just create another node here. 1, 2, and put them both to multiply. And then this is important. The X goes into the one that is going to be rotated in the Y axis. And the Y output is going into the one that is rotating around the X axis. So, let's try it out. Let's actually get the whole thing. Go into edit mode. Rotate it around the cursor with Z. And we can see that it actually works. So we can now move this anywhere. Thing is, the handle needs to be kind of straight for it to work. So it does not quite work in every direction or when it's too steep. But when it's over here, for instance, it's totally fine. And to be fair, mushrooms don't really grow sideways. Yeah, it seems that if you want to put it past 90 degrees, it kind of stops working. So it works up to a certain point, which is acceptable for me. It's starting to look pretty good. The mushroom can already bend. And we already have this nice little cave in. Next thing we're going to fix is actually that it also caves in here. So to do that, we're going to go back and create a new attribute statistic node with this curve over here. So the curve that's only 4/5. Let's drag it all the way over here to about the end of our equation. And this time we're not going to look for the normal, but we're going to look for the position. Plug that in. And let's also do the endpoint selection. So we check the position of the endpoint. Next thing we're going to add is a vector math node and set it to distance. And we want to get the distance from this point over here, which is inside our cap, to basically everywhere else. So we're going to plug the position over here and then put the median here. So the point is somewhere in here, the endpoint is in here. And for every point on the surface, it's going to calculate how far it is from that point in the middle. And now let's get another float curve. And also get another multiply node and plug those in. So now it doesn't look good. We actually want to have the output as 1 when it's very close and 0 when it gets very far away. So to do that, we pull this up. You can see now it works. It has to be up for a little bit because you want to check around this sphere, I guess. And then pull it down really fast like that. So now we can see that this hole is filled and this here still works. So that's even better. We have that mistake covered. But one last thing, and this is my favorite part, is actually these frills over here. That you can see in the normal mushrooms. You have these frills under the cap where all the spores are located. And that's also going to be part of the same mesh. This is all one mesh. That is why it's so cool. Also, my camera is almost dying. If I just disappear suddenly, it's because of that. I don't have time to charge it. Anyways, let's pull our whole equation down so we actually have some room over here. Get that as well. Doesn't look very pleasing. But here it's a bit better like that. And what we now want to do is actually move this out of the way for a sec, and we have to make a little frill mesh, I guess. So we're going to make a circle, and based on how many vertices is in the circle, that's going to be how many frills there are going to be. I've tested it now with, I think it's 12. So let's do that. You could actually do this in geometry nodes. I just do it with an object because it's a little more easy. I'm going to go into edit mode and fill that up, and then press Ctrl F, go into the face menu and poke these faces. So next thing is we want to select the outer rim by pressing Alt and selecting the outer rim and remove all the edges, delete all of those. So finally we want to select everything and extrude that out upwards, I guess 0.2, and pull it down by 0.1. Maybe it can be a little thicker. So let's actually make it a little thicker. Like that. You need this kind of shape. And I'll show you why this shape is actually useful for creating the frill. So let's create a object info node. And let's also make an instance on points node. And we're going to need this curve over here. So by shift dragging or shift right click. Yeah, shift right click drag. You can make this control point and then you can easily plug that in. And we actually want to have another endpoint selection node. Set that again to 0, 1. Plug that in. And for the object info nodes, just select our circle here or our frill thingy. And finally, we will get a curve tangent node. And a align Euler to vector node. Put it into the Z and put that into the rotation. And let's actually get a viewer node to see what's going on. Also get a join geometry so we can both see the instance we've created and the mesh itself. So this is how it looks. And you'll see it's not rotated. I made a little mistake. This actually has to go into the vector output and not the rotation. So now you can see that it's following along quite nicely. Next, we're going to add a realize instances node. And we're going to add a geometry proximity node. Put that into here. The geometry node proximity works with a target, which is our frill here. You can see it right now. Let's plug that in again. Yeah, works with our frill here. And we're going to see how close the vertices of the mushrooms are to these little flaps that we've created here. So how do we do that? We do that with the new sample nearest surface node. This replaced the transfer attribute node in 3.4. So if you've never used it, this is a new node that's very useful and it frankly works better than the transfer attribute. Let's get the position and put that into the value, actually, sorry. And put that to vector. I have to reconnect it. And connect the mesh. And we're going to put this vector into the source position. Now, how does this actually look? Let's put this in the viewer. And we can see, even better if we actually hide the frill, we can see that we have these little lines over the geometry. And these are perfect for creating this frill effect. What we want to do is create another multiply node. And we want to connect the distance to the multiply node. Turn off the viewer and let's see how that looks. You can see it a tiny little bit. So here, if it's not connected, and here, if it is connected, you can see the tiny little bit. So how do we make this more pronounced? We're gonna make a float curve yet again, and make this a very sharp corner, just like that. And you can already see this lovely frill effect taking hold. And again, play around with the flow curve to see which settings are most matching for your mushroom, which you like best. Now I'm actually seeing how this appears frilled as well. So let's troubleshoot that. Let's actually reconnect this because I feel like it might be going up a little. So we maybe made it a little too thick. We can fix that easily by actually selecting it and just maybe go a little bit down like that. That's much better. So the top stays nice and smooth, and we have this textured frill effect at the bottom. And there's actually another little fix we want to do, because if you do the grow thing right now, it doesn't look that good. So we want to actually make it so it closes up, or it opens up later in the grow stage. And to do that, we're gonna go down here. This again is the flow curve that checks for the normal over here. So it checks for which part is going to be pushed up. And we're just gonna put another multiply node here. And also create another flow curve. And let's get our group input. And connect the grow to the value. And let's set it kind of like that, maybe. It should probably go straight, like here. And then just multiply that. You can also maybe play around with this value, these values a little more. Maybe it can be a wider selection. Actually, it doesn't look that bad. Okay, so we have our mushroom mesh. Let's make a mushroom material. And before we go to the material tab, we actually want to create a attribute right here, which is the length of the curve. So we can actually use that in our material tab. So let's create a store named attribute. And get the curve, I guess right here is fine. Let's get the spline parameter and get the factor of the curve and name this mushroom. And then just pass the geometry over. Still works. We can go to our shader editor now, create a new shader, and get our attribute. So mushroom. Oh. And let's just get a color ramp so we can see how that actually looks. Go into material view over here. Plug in the color. And you still see nothing happens. And we did everything correctly, but we have to make another node called a set material and put that at the very, very end and click our material. I don't know actually which one it is. Could it be this one? Let's see. It's material 1, so it's this one. And we can see that it works. So it's dark right here and bright at the top. You can pull this up. And we already have a little black and white mushroom. Now I'll quickly show you how to make the simple material that I've made in the preview. So let's actually pull this down. We put another one. Let's see here. Create this brown stem and then the dark brown top. And then actually I made this a little blue and dark. And we can also put this in the subsurface color. And then put the subsurface on... Actually, let's also use a color ramp for that. Because we can make the top less see-through and the stick more see-through. Let's put this over here. Maybe turn this up a little bit. And this down. And let's also put it to ease so it's more smooth. And put that into the subsurface. So let's actually look at this in cycles. Because I enjoy cycles more. Well, this is actually the top, isn't it? This is actually the top, so we have to switch these two around. And let's just darken this color. Putting this to black. Let's plug that in and we're gonna darken it with a noise texture. Grab a color ramp and put that into the factor. Connect that. And so here it's white for more dark. So keep that in mind. You can turn this down a little bit. Maybe bring it a little more together. Give it more detail. a little more roughness. You can also give it a slight bit of distortion. Could look to make it look a little more funky, a little more magical. Just like that, just a simple material. And let's actually also create a little bump map. So create a bump node. Gonna do another color ramp. On the same noise output, actually pull that down. Put that into the height and put the normal into the normal. So it's very, very, very crunchy mushroom here. So let's actually bring the strength down to 0.01. Okay, so now we can barely see it, maybe 0.08. Already starting to look a little better. I'm also gonna just look at this coloring over here. And yeah, just play around with a lot of these values. There are a lot of procedural material tutorials out there. Just make sure to use this attribute, because the attribute is so useful for just creating colors up and down this lovely mushroom. Yeah, so this is the end of the tutorial. I hope you liked it. If you've watched it this far, you are a legend. Thank you so much for watching. Make sure you subscribe for further tutorials. I'm gonna probably do this more often. Yeah, see you later.